we are going to see about the Unit 3 pulse modulation and multiplexing. We have the analog pulse modulation PAM, PWM, PPM, digital pulse modulation, PCM generation and reconstruction, delta modulation and adaptive delta modulation, multiplexing techniques. We have time division multiplexing and orthogonal frequency division multiplexing. In the analog pulse modulation, we have some parameters of each pulse of carrier wave being modulated by a particular sample value of the message signal. We have different types as pulse amplitude modulation, pulse width modulation, pulse position modulation. In detail, we are going to see about pulse code modulation. The pulse code modulation is essentially analog to digital conversion of a special type where the information contained in the continuous samples of an analog signal is represented by digital words in a serial bit stream. The PCM output is in the coded digital form which has constant amplitude, width and position. The available range of the signal voltage is divided into levels and each is being assigned by binary digits. The number of levels n is equal to 2 power m depends on the number of bits. The analog signal is given as the input to the PCM encoder which has sampler, quantizer and it is being encoded to get the digital data. This is the PCM generator. The X of t is being passed to a low pass filter. It is sent to a sample and hold circuit. Q level quantizer, binary encoder is being converted to parallel to serial converter. We get the PCM signal. The pulse code modulation technique samples of the input signal X of t at frequency Fs is greater than is equal to 2 into W. This variable amplitude pulse is then digitized by analog to digital converter. The parallel bits obtained are converted to a serial bit stream. The input signal X of t is first passed through a low pass filter which blocks all the frequency components above W Hz. The sample and hold circuit, it is then sampled with the signal at the rate of Fs. The sampling frequency Fs is selected sufficiently above Nyquist rate to avoid aliasing effect. So Fs should be greater than or equal to 2 into W. The output of the sample and hold is called X of NTS. This is discrete in time and continuous in amplitude. The Q level quantizer compares the input X of NTS with the fixed digital levels. It assigns any one of the digital levels to X of NTS with its fixed digital levels. It then assigns any one of the digital levels which results in minimum distortion or error. This error is called quantization error. This output of the quantizer is a digital level called XQ of NTS. The quantized signal level is given to a binary encoder. This encoder converts the input signals to V digits binary words. Thus, XQ of NTS is converted to V binary digits. The encoder is called digitizer. It is not possible to transmit each bit of the binary word separately on transmission line. Therefore, V binary digits are converted to serial bit stream to generate a single baseband signal. The V digits will be denoted as Q is equal to 2 power V. The signaling rate is given by R is equal to V into Fs, where the bandwidth is given by Bt is greater than equal to 1 by 2 into R, or 1 by 2 V into Fs, or it should be greater than V into W. So this is an example of the 8 quantized level. The bit is being quantized and the restored signal. The PCM receiver we have PCM signal plus noise being given to the regenerator, signal to parallel converter, digital to analog converter, sample and hold circuits with the low pass filter. We get the output. The regenerator receives the PCM signal along with noise. It reshapes the pulse and removes the noise. The signal is then converted parallel to digital words for each sample. The digital word is converted to analog value XQ of t with the help of sample circuit. By using low pass filter, the original signal is converted to X of t. So this is the original signal x of t. Thank you.